Hey.
All right, my friends. What do we get for a final answer?
1,256.2800.
What'd you guys get? 76. What's the pennies?
30. 36.
28-ish. Okay, now take a look down below. All right, and they start doing it in formula form. We're not going to look at all that derivation stuff. That gave me a headache yesterday. But I want to remind ourselves what some of this stuff means. P1, P with a little 1. What does that mean?
The starting point over a year.
Okay, that's how much money after a year. Money after 1 year. Okay? P0. What was P0?
Starting point.
Write this down in your book, please, Brody. Starting money. Okay? And what's R? Rate. Okay, now this formula that we're looking at is the simple interest formula. And then they go through some steps. They're going to get us the compound interest formula. Let's see. Here we go. Substitute, blah, blah, blah. Here we go. Compound interest formula is, we're going to write it in number 4. So over on the next page, shrink it down a little bit. PT, principal after a certain amount of time, equals P0 times 1 plus R with an exponent of t. Ooh. Well, that's a 1. 1 plus r. The principal, after a certain amount of time, you're going to find by using the starting amount times 1 plus r raised to the time as an exponent. Let's see number 6. We're going to use that in number 6. Okay, write an equation. Tony, could you read number 6 for us?
Write the balance in Raoul's compound interest account as a function of time t. Recall that the original principal is $1,000 and the interest rate is 5%. Use the function to verify the values in your table.
Okay, so we want to use that formula that I just gave you, and we're going to give it Raoul's numbers. So the first thing we're going to do is go PT equals, Andy? PT equals. The next thing in the formula is P0. What did Raoul start with?
Used to do with 1,000.
1,000 times parentheses 1 plus r. What was Raoul's rate? 5, but in decimal form, 0.05. Close the parentheses. And now we're going to raise it to a t. We can simplify that a tiny bit. You got this written down, Andy?
Yes, I do.
1,000 parentheses. You don't really need to write the times. If you put a number in front of the parentheses, that means times. What happens when we go 1 plus the rate? What does that? 1.05 raised to an exponent. Now, they wanted us to verify with Raoult's number. Okay? Excuse me? Oh, rats. There you go. You can make it smaller and you can fit more in. Could you pick a number between 1 and 5?
6.
3. Kenya's picking 3. We're going to write right here in this space for time. Let's do t equals 3. So we're going to use this formula to see if we get the same thing as we were getting in our table. Here's how it works. P3, you put a little 3 down below. That means how much money's in the account after 3 years. 1,000 times. We simplified it by putting in Raoult's number and adding 1 plus the rate, so 1.05. Now, for the t, we're replacing or substituting in a 3. That's the time of 3 years. Here's how you do that in a calculator. Turn your calculators on, clear them on out. 1,000 times 1.05. Are you with me to there?
Yeah.
Is it in a calculator with me to there? Now, in order to do an exponent, you need this little caret button. It looks like a tent, a little pup tent. It's right underneath clear. You're going to push the caret button, and we get a blinky light up high. That's where we're going to put in our exponent. Are you with me to there? You've got 1,000 times 1.05. You've done the little blinky light. We're going to put in 3 based on, we're finding it for 3 years. Now we're going to push enter. That's the amount of money that should be in Raoult's account in year 3. Check our table. Does it match what we got before? Okay, so this equals 1,157.625. So this formula we could use for Raoult. This generic formula we could use for other people depending on their starting amount, interest rate, and the amount of years you're figuring. Okay, because sometimes it's easy to do a table if you're doing 1, 2, 3 years, but suppose you want to save it for 15 or 20 years. You don't want to do every single year over and over. Times add, times add, times add. Okay, so formulas let you project out further. Flip the page. See what they have for us. Determine which function family represents a compound interest formula. Explain your reasoning. So PT equals P0. First thing to know, can we tell what function family it is just looking at it? Hello? Anybody out there? The variable that we're most interested in is right here. So for example, if we were looking at Raoult's, what kind of function family is it when your variable is up here in an exponent? Okay, who said that? Molly thinks it might be exponential. All right, let's go ahead and look at it. Go to y equals. In your calculator, go to y equals. Let's see if this is an exponential function. All right, we're going to go 1,000 times 1.05. Raise it to an exponent. So I use that little caret which is underneath the clear. I have the cursor blinking right here, and I'm going to put in my variable right there. So I push the xt theta n button. 1000 times 1.05, put the x up here. Graph. Oh.
Yeah, mine made it a straight line.
Okay, go back to your y equals. Did you push the caret button so that the x is up high?
How do we raise
Some
the
people
Y?
put.
Excuse me?
I think some people put like a letter number.
They put the x right there.
Do you put a number?
Looks like an arrow.
Oh, did you put a number in? You got to put in an x right here. Graph. It should look like a curve. Depending on your size of your window, how much of a curve you're going to get. All right?
Don't we have bigger windows?
Oh my god.
But if you have a straight line, it's not a window issue.
I don't have a line.
Okay, y equals so this is wrong. That x did not go up. So let's see. 1,000 1.05 caret x.
That's good.
Like that's what it was. This one I hear it pushing up there, but it's still. It's gonna be like
Flesh. I like vegetarian hunting. German shirt? Is she look healthy for your ankle? We'll let her go. We got good barbecues. It's like Indian seals and seals no, one time I stuck circle hooks in a piece of bait and fucking threw it and let him die because he kept dude, every time I run to the water
Let's see.
to cast,
Is it the problem with silver calculators?
I run away from my shit to cast in the water and then run back and as I'm going back he's flying away with my fucking tortilla chips and shit. So I just and it's just like shit kind of looks at it. And I got the exact same thing.
Alright, excuse me. Let's not digress too far into how to work a calculator land. What shape is that? Is that linear? Is that linear? No. Okay. Is that an exponential function? Look back. What page was that on? It was way back in the front where we had our function families. Okay. Back in the front, function families. 48.
She said for you.
Ruby's trying to talk.
Thank you, Ruby.
Remember wave your hand.
You guys got it. Are you guys looking at your page 48?
There's a spider behind you.
What do you notice?
They're all curved.
They're all curved. Does that match our...
Oh yeah.
Okay. Simple interest, Andy, was a linear line. It was part of the linear family because it went up the same exact amount every year. This one curves because it's going up a little bit more and a little bit more and a little bit more. The interest is getting bigger and the pot is getting bigger quicker, the amount in there. Okay. Use the function that you wrote in question 9 to determine account balance after 8 years. So P8 equals, Andy, what am I going to write next? Parentheses. Guillermo, what goes inside the parentheses?
.05.
1.05. Okay. There's going to be an exponent. 8. Go ahead, put that in your calculator. Clear out of your graph. To get out of your graph, push clear. 1,000. Raise it to the exponent of 8. I've got, what do you got? I'm wrong? That's what I'm getting. 1477.45. 100 years, P100. Use your calculators. Find P100 for us, please. I'm walking around. Woohoo! That's a lot of money.
I wish I had.
100 years pays off. Yeah, I gotta do the
That's
carrot.
about.
I got 162889647.
Oh, yeah, that's
Zero, 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 one, 4, 2,
Yeah.
6, 7, 8.
Instead of 8, put 100.
Dude, my computer won't connect to the Wi-Fi. I'm getting mad.
Raise the hand.
Okay.
After why did you get
Hey, Ruby.
Hi, Ruby.
The rest of you need to be quiet. They said you were trying to talk. Were you trying to tell us something? No, they were teasing me? Okay. They were trying to talk to you. Okay, there we go. All right. Hey, let's see. Anna, did you get an amount for 100 years?
Yes. I got 131,501.2578.
There we go. Okay, now the intersect feature was interesting. This is amount of money that we're trying to see when does the bank get up to that amount of money. For the intersect feature, we need two values in the y equals. So push your y equals. If you still have your function in, that's perfect. We still need that function as one of them. Then we go down by pushing this downward, left, right, up, down, so that you have a blinky cursor in y2. Now we're going to put in 1600. We're going to try and figure out where does Raoul's curve intersect that amount of money.
You got a table?
Okay. You could go to table or you can go to intersect is in calc. So you're going to go second calc. Second calc. Blue button calc. And you guys see the word intersect there. What number is intersect at?
5.
Are you doing that on your calculator too? Okay. So I'm going to push 5. Oh. So what that is, this line, quiet please. This line is Raoul's bank account. This line is that flat amount of money. What you're trying to figure out is that's the spot then where his bank has that much money in it. To find it, see where it says first curve question mark? Hello? It says first curve question mark. After you've pushed intersect, push enter. Then second curve, push enter. And then guess. Oscar and Sam, are you doing this on your calculator? Push enter. Okay, now we get two numbers down at the bottom of the screen. I'll make my calculator bigger. See where it says y equals and x equals? What does it say for y? 1,600. Okay, and my little cursor is right where those hit. What does it say for x?
9.63316.
That's how many years. That's how many years it takes for Raul's bank account to have that amount of money. So put that right here. T equals 9.63, we'll call it. Now, what did Raul start with? And so what's double of 1,000? 2,000. So we're going to do the same thing for 2,000. The question we're trying to figure out is where does this function equal 2,000? So what you're going to do is leave that function in y1, go down to y2, and change it to 2,000. Now we're going to find the intersection. Intersection is in calc. So we're going to push second, calc, and 5 again. Takes a little bit to draw the new lines. Notice that line is a little higher. Now it says first curve question mark, you push enter. Second curve question mark, you push enter. Says guess, you push enter again. And this little blinky cursor is right where those two crisscross. This is the flat 2,000 line. This is Raul's bank account. And what does it tell you for X?
14.20.
That's how many years it'll take for his bank account to double or to reach the amount of 2,000. T equals 14.21. Alrighty, that's enough of this. Okay? Right now, close that over. Don't move. Ruby. Oh, rats. That was the wrong thing. Sorry. Looking at your arm. Ruby, do you have questions on the homework packet from this week? Okay. All right, guys. Say goodbye to Ruby.
Bye, Ruby.
Wait. Here. Near zoom out.
Oh my God.
Now she can see you guys. Now you can say goodbye and wave. Alright. And we'll see you again sometime. Alright, Ruby? Bye. Okay. I think I hang up with that. Alright. Nope.
She has a question.
Disconnecting. Okay. Excuse me? Yes. This is like old school FaceTime. Okay. Now, I need books and calculators.
Hold on.
Close the door. Thank you. We're close. We're close. Where's the calculator box? I'm a little strappy here today. Can you be the counter for us? No. Okay, we need calculators over with 14.
I'll do it all. 7, 8,